Okay, guys, let's take a look at this Big Bang Theory just a little bit more, okay? And up there in green, you can see we've got it that it started around 13 to 15 billion years ago, and this event created the stars, planets, galaxies over time that we see today, okay? Now, I like this slide because you're going to see this picture that I have here in black. If you take a really close look at it, what you've got here is, and I don't know if you can see my cursor, but on the far left of the in this black picture here, it's you've got this bright moment. Okay, that's the event. What triggered it? We don't know. We don't know. But what triggered it was a sudden expulsion, or everything moved out in a way from that one spot. And then what you've got here along the bottom of that picture is you can see the time frame, 13.77-ish billion years ago. And you can also see that the first stars were formed. Now we know how those happened, at about 400 million years ago. Okay, we're going to go into it more, but this chart, I wanted you guys to see this chart because it really gives you a good idea of the time involved and what happened. I'm going to show you a different slide here right now. Okay, this is kind of cool because it's kind of a lot to take in. But if you go to number 1, okay, suddenly at some moment before time began, we have an inflation, we have an eruption, we have an expulsion of stuff. Okay, pay attention in number 1 to that word, the size of an atom to that of a grapefruit in a tiny fraction of a second. I mean, we mean everything erupted at some moment. Okay? Now, at number 2, we are still less than a second away from the moment of number 1. Okay? Check that out. Post-inflation. Okay? The universe is seething hot soup of electrons. Electrons is about all we can build. It's too hot to even form an atom. Whoa. Now, number 3, we have a little bit of cooling happening. We're still less than a second after that event. Whoa. Okay. Now we've got enough cooling that we can just now start to have protons and neutrons. Remember, those are parts of an atom. We're just barely cool enough that those things can actually exist. 4, okay, we've got some atoms that are starting to take place. The simplest one obviously being hydrogen, right? We got one little proton, one little electron that spins around it. 5, 6, and 7, they take place over many more years. Now look at number 4. It says it's 3 minutes after the event. Whoa. And then 5, 6, and 7, you can see that we're at 300,000 years after the event. Okay, we've got atoms, mostly hydrogen and helium, and light can finally shine. What? Then we've got 1 billion years ago, and then at number 7, we've got 15 billion. Hold on, there's a easier way to look at this. Okay, step number 1, what happens? We barely got any atoms, we've got particles, we have expansion and explosions. That's 0 seconds. Okay, we're at number 2, we're still within that first second after the event, right? We got electrons flying everywhere. We've got at step 3, that's 1 second after the event, we've got electrons that are and some atoms that are starting to form. Okay, 4, you're familiar with. 5, we looked at, right? We've got some protons, we've got some, parts of an atom forming. Okay, we have gases collapsing at step 6. Okay, and we get stars just being able to be formed. We have to jump a big length of time between 6 and 7 because 7 is where we are now. Okay, so where did all this start? Well, we're going to identify some key things that we need to be able to put together of like how it all started, where the idea came from. This is not really covered in what we need to cover, but I wanted you to know where it did in fact come from. There's a guy about 1927. Okay, that's 14 years after the Titanic sank. His name is Georges Lemaitre, and he was studying physics and mathematics after serving in World War I. He became a priest, a Catholic priest, and he was so into this math and physics that he began to study astronomy. And he found through the math that the objects in space, the galaxies, are moving away from each other. And he found a mathematical way to represent that. And yeah, he hung out with Einstein, at the time. But his idea was this, that the universe is constantly expanding. He proved it through math. So he publishes his theory. Again, this is 1927. This is, the 20th century. But now here's where it all kind of starts to come to this Big Bang idea. If everything's moving away from each other, then it makes sense that it's moving away from a point. So he called that point the cosmic egg. And you can see that down there in red toward the middle bottom right there. He proposed the primeval atom hypothesis that the universe began as a single point out of a cosmic egg. And the cosmic egg is what we identified in the previous PowerPoint as that singularity. That point, that spot in 3D space. Okay, and it didn't, when he threw his idea out there, it didn't really gain a lot of popularity because it sounded too religious. Honestly, to a lot of people, it sounded too much like Genesis. But isn't it funny? That's what the math proves. Hubble, that we named the Hubble telescope after, publishes his work about the same time, but he based his on something a little different. But the two didn't really conflict, he just... Okay. Okay, so for our purposes, really we need to look at who started it all. And I mentioned this guy in the previous slide, Edwin Hubble. Now he also discovered that there's galaxies beyond ours, but one thing he noticed about him, here's what he observed that made his a little more scientific than Lemaitre. He noticed that the light from distant galaxies was changing in color. It was shifting toward red. Think about the colors of the spectrum, Roy G. Biv, red, orange, yellow. Okay? So what happens is when light is being emitted by something and it moves away from you over a great distance, let's say that color was yellow. Because light is part of the electromagnetic spectrum, y'all know that from 7th grade, what happens as that light goes over a farther distance is that the wavelength of light stretches. Instead of being real tight like mountains, it stretches out like rolling hills because it loses energy. So if an object is moving away from an observer, the light will shift toward red. We call it redshift. So to kind of sum it up and give you number 2 in your notes, Edwin Hubble detected that light from distant galaxies was doing what? Shifting toward red. You wouldn't be wrong if you also wanted to put on that line, instead of shifting toward red, moving away from us. Because one brings about the other. Okay, so for number 2 in your guided notes, the light was shifting toward red. All right, so let's deal with number 3. This is one of our evidences, the Big Bang. Is what do we call that when the color of light shifts? We call it redshift. Okay, one of the evidences used to support the Big Bang is redshift, which is when the what of light, or the what of waves? The wavelength of waves stretches out or lengthens. Okay, so in the previous PowerPoint, you covered number 1. I just went over 2 and 3. For this week, y'all, you're done. I need you to snap a picture of 1, 2, and 3 written out and upload that, and I'll get your grade in sometime over the weekend. And you shouldn't be given any more stuff on Monday. Monday is a non-student day, so I'm not going to post anything for you either. So you take that day, and it shouldn't be anything new from anybody. That's the way it should go. Alrighty? And don't worry about the vocabulary because I haven't unpacked it for you yet, or for you guys yet. So you guys have a great weekend. And as always, if you need anything, holler.